So let's check out the first type of math problem we'll do in these. Remember that when it says product, well, you're talking about times. If you know that already, you don't have to label it. But if you don't, get that in there. And then in the previous slides or whatever we did in the last video, we talked about exponents. So this is like the power. So we're talking about multiplying different powers, different things with exponents. And for these beginning ones, I'm going to be a little bit more thorough in some of these explanations. So we're talking about multiplying different powers. Now here we're told to simplify each expression, and right now this is made up of 1, 2, 3, 4, 5 terms. Now since this is new, over to the side, I'm going to show the long way of doing this. Well, let's rewrite x squared times x cubed, because as I look at it, those parentheses really don't matter. What they're doing is they're kind of giving us some training wheels to see this better, but then also making us flexible with dealing with parentheses. So x squared times x cubed is the same as, well, what's x squared? That's x times itself. Well, what's x cubed? Well, that's x times x times x. And if I write this out neatly enough, and I think you can keep that better than I did, it's being multiplied by itself 5 total times. And I think that's really helpful that I see that, well, on the left side I can say, well, how many times is x multiplying by itself? Twice. How many times here? 3. Then how many times total is that? So I'm going to write x to the 5th, and I have simplified it. I have gone from having two separate looking monomials really just combined to one, because I can put x's together because they match. Same deal as before. We have this y to the 3rd times y to the 4th, and I think you'll probably have room on your page to rewrite this. Sneak a times symbol in there. Well, that means that the first one is y times y times y, and then times y times y times y times y, because it's 3 and then another 4 times. So that appears for a total of 7 times. Now if that's unclear, make sure you're pausing this video, maybe revisiting what I said, but all we're doing is multiplying the same variable by itself multiple times. Now I have a ton of different examples here, so maybe I'll do a little zoom action so that my writing's a little bit better. Alright, I see another example where it says 4 times and then n parentheses 2y cubed. Well, I only see this as 4 times 2 times y cubed. Now my eyes like to scan everything from the left to the right. And there's only so many things going on here. We have some values that if they were written on their own, we could call them constants. And they're really just regular numbers. I only have the appearance of one variable. So I scan from left to right, and I look for any that are just numbers. So I see the number 4, and I see the number 2. And I know that left to right I'm doing 4 times 2 is 8. I scan through again, and I'm being very thorough in these new ones. Do I see any other just numbers? Now, yeah, 3 is just a number, but that's an exponent. So when I say just plain numbers, I mean numbers being multiplied. So now I move on to the variable, and I see, well, how many times does y show up? Well, it shows up just once with an exponent of 3. So 4 times 2y cubed is 8y cubed. Let's check out the example on the right. This example is 2 times 3 times 4x squared times y. And for this one, I will rewrite it again, only to communicate that those variables really don't matter. And that's in, those parentheses don't matter. And that's in parentheses, but now it's without the parentheses. So let's look at this. Let's do a scan from the left to right. Well, I see 2, I see 3, I see 4, and I'm not going to write 2 times 3 is 6, because I think we can balance that 2 times 3 is 6, times 4 is 24. So if I can, and I'm not cutting too many corners, and it's not like there's numbers over here and crazy things, I don't think that that's cutting much of a step there. I'm scanning through left to right. I didn't miss any numbers. Yeah, I missed this 2, but that doesn't matter because that's the exponent. So now I move on to my variables. And usually you start earlier in the alphabet. And it's kind of like you hear X, Y, Z, so I know that X is earlier in the alphabet. So I scan through, and X only appears once, and that's to the power of 2. So I'll write 24x squared. Now again, we scan left to right. Do we see any more X's? Did we make a mistake? No. Well, then let's move on to Y. And I only see Y once, so I will write 24x squared Y. Now you need to know this. That's only showing up once, so I could put a power of 1 on there, and that would work, or I could just leave it as is. It's better to leave it as is because the better you get at it, the more you know that that's the way it is. All right, let's pan this down. Let's check out this example on the left side. This time I will not rewrite it. I think we're feeling good. So we're scanning left to right. We're looking just for regular numbers. I see 5, I see 3. I know that there's times and times and times and times. So I'm going to say 5 times 3 is 15. Okay, I move on. I'm done with my numbers. I'm ready for some variable action. So I see x squared, I see x cubed, and I know that I'm just going to add those x's and their exponents, and that's going to be x times x times x times x times x, which is x to the 5th. Moving on. Let me clear the page and slide this. Oh, I think you'll be fine. Sorry about that. I'm sure that didn't trip you up too much. Let's look at this one. Okay, scanning left to right. 5x to the 5th, x to the 6th times x. Well, here I have just 5. There is nothing I would combine it with. Now, optionally, add a 1 there, and it'll help you see that x is being raised to the power of 1 on there. Well, that means that x is being multiplied by itself 5 times, 6 times, and another 1 time, and 5 plus 6 is 11, plus 1 is 12. So this is 5x to the power of 12. We'll move to this example next. X to the 5th times x cubed times y to the 4th. I scan left to right, and I'm looking for just constants, coefficients, whatever we want to call them, and I see none. So if you wanted, you could write 1, or you could just leave it off. I look for my earliest in the alphabet variable. I see the letter x. Now, even though these parentheses are here, they don't matter. It's not like I have something inside of parentheses being raised to a power. Then that would be altogether different, and we'll see that in a bit too. But these ones just have parentheses around it only to kind of hold it off. So this is x to the 5th times x to the 3rd is x to the 8th. Now we'll move on to y. Same as before. I know that that's to the power of 1, and 1 and 4 will give me 5. Variables next to each other, separated by exponents, do not need a time symbol. I say leave it off. Now, as we've moved further and further into these, I'm going through them more quickly, and I hope that's okay with you. So I look at this, I see no values and no regular numbers. I see x to the 3rd, and I see x to the 5th. I'm going to combine that to be x to the 8th. Now I move on to the letter y. I see that to the 2nd as well as to the 4th. I'm going to say y to the 6th. Make these next two OYO problems. I will put the answers up, and then I will explain them. I'm going to begin explaining it in just a moment, so pause this video if you have not already. I feel this one's pretty straightforward. 5 times 7 is 35. Y to the 4th, y to the 5th becomes y to the 9th. 2 more seconds before I explain the next one. 1, 2. Negative 4 times negative 6 gives me a positive 24. R to the 2nd, R to the 5th gives me R to the 7th. S gives me 4 total, and T gives me 6. And here's the deal. There's a lot more going on here, so I probably finish the problem and double-check everything and think, well, negative times a negative turns positive. All right, I'm good there. I scan through. I look at all the different numbers. Good there. Scan through, do a double-check on all the R's. Same comment, same comment. And obviously, you know, the more steps are involved, the more likely it is that you'll leave something off by accident. Okay, now, we were just dealing with the product of powers, so now I'd like to resolve this a little bit. Let's talk about this with symbols. Let's talk about it with examples. Now, I stayed away from the algebraic rule because I think it's better to see it to begin with. With symbols, what's most common is that they write the letter A. Well, in these ones, when we were able to combine them, the bases were the same. But we had an exponent of m, some value. So it's like a to the power of m. Whenever a to the power of m is multiplied by something with the same base to a different power, all you have to do is take those separate exponents and add them together. So what this is it's a to the power of m times a to the power of n becomes a to the power of m plus n. Now, on purpose, I avoided this until you did the problems because I think it's way clear when you're dealing with something that's an example with numbers. Well, 2 to the power of 3 times 2 to the power of 4 is the same as 2 to the power of 7. We took the first exponent, added it to the second exponent to get the final exponent. So yeah, it's very clear to me that 7, well, that's just 3 plus 4. And if I look at it with an example, it helps to make this abstract symbolic representation a little bit more clear. Similarly, I'd like you to write another example where it's with variables. X cubed times x to the 4th is x to the 7th. It's basically the same as the one above. And here's what I'm comparing this to. What I'm saying is that x to the power of 3, x to the power of 4, all you do is do 3 plus 4 to get 7, so you're just adding those exponents. For me, that would be crazy helpful in learning this new concept, and I would rather do that after seeing the examples because it helps me remember why it works the way it does. We'll stop this video before the final of these notes.